Hello everyone. Before diving into more in execution plans, we need to understand parameter sniffing in SQL Server. This might be an easy topic for you, but believe me, many performance problems can be resolved by deeply understanding this topic. Let's get started. Let's first understand how parameterization works in SQL Server. I ran this query first to show how it works. Here, firstly, I am cleaning execution plan cache by using dbcc freeprog cache so that the new execution plans are generated. Also, I'm using state province ID parameter and changing all the ID numbers here. Let's check now how SQL Server is generating plans. As you can see, SQL Server is generating different plans for each query, even they only differ in the value of state province ID. I expected SQL Server would parameterize these queries and use the same plan for each of these queries. Why different plans are being generated? The reason is the difference in the number of rows. With ID 59, only one row is being returned, while with 79, more than 2,600. So SQL Server is finding it is inefficient to use one plan and generating two different plans, one with index scan and one with index seek. Very smart, isn't it? Let's now see example where parameterization is created. I run this query again with different IDs. As you can see here, with these two IDs, only one row is being returned for each ID. If we check query plan, we can see that the same plan is being used. Because SQL Server finds that one row is being returned for each ID. So SQL Server decides that it is safe to parameterize address ID and use the same plan. So what we can conclude? SQL Server does not always parameterize queries. Sometimes it generates different plans, although all the value is different, because it considers two different plans are needed based on the statistics and the number of rows being returned. However, sometimes there might be some special cases where you want to parameterize similar queries if you know that using the same plan can provide better performance. In that case, you can use this query and enforce parameterization. Now let's again run our first query. As you can see, now SQL Server is parameterizing and using the same plans for two of these queries. Now let's cancel enforcing parameterization now. You can also use stored procedure to enforce parameterization. For example, by using this command, we create stored procedure. If you run this stored procedure with again different values, you can see parameterization is created and the same query plan is being used. So why do we need parameterization? Query optimization and generating a valid plan is an expensive operation. By using parameterization, we can use one plan for these queries which differ only with parameter values. If one plan can be used for the queries which differ only with parameter values, we can skip optimization cost in terms of optimization time, CPU resources, and so on. Therefore, parameterization, I can say, is a very much important process. Let's now talk about parameter sniffing performance issue. We understand that after creating stored procedure, SQL Server is forced to do parameterization and one query plan is generated for all the values, right? However, as we saw already, this one plan might not be optimal for all the values of the parameter. There might be cases where different plan is better for specific value of the parameter. I'll show you one more example. Let's create stored procedure by parameterizing product ID. If you run this query, you will be able to see that parameterization is happening for product ID and this index seek operation is being used for all the values. But is this plan optimal for all the values of product ID? What do you think? I don't think so. Let's run this query by enabling statistics. As you can see here, we can see the logical reads is around 40,000, although we have 4,688 rows. Therefore, it is using over 14 times more I/O operations than just simply scanning the entire table. Here, not indexing but index scan would be more efficient. Let's clean the cache and rerun the stored procedure so that a new plan is created for this value. Now, as you can see, index scan is being used instead of index seek because SQL Server is finding this plan is more efficient. This is considered a performance issue in SQL Server coming from parameterization, and we call this as parameter sniffing issue. Now, how to resolve this? First option is optimizing for particular parameter. You can just use hint called optimize for, which is useful when optimal plan can be generated for the majority of values that are used in specific parameter. In addition, it can provide more plan stability. For example, here, suppose that the plan value 897 can be an optimal. Next option is recompiling for each value. Also, if you don't use stored procedure or use exact values instead of parameters in stored procedure, parameter sniffing does not happen. Okay, so you can use separate queries, statements instead of stored procedure. Finally, you can just use this query to disable parameter sniffing. One interesting problem that we have sometimes when a stored procedure is taking too long to execute or timing out on web application but returning immediately when executed in SSMS. Although there could be a few reasons for performance problems like this, including blocking, the most frequent reason for this is becoming two different plans were created with different set options. If a different client running the same stored procedure has different set options, it may generate a new plan instead of reusing the one in the cache. As a result, you might face different performance among the clients for the same query. These are the set options. Unfortunately, Management Studio, .NET Framework, and even SQL CMD utility has different set options in the default configuration. You will find that often the problem is that one of the set options, for example here, this option is off by default in .NET and on by default in Management Studio. Let's create test database for testing. We can see set options of SSMS from here for this session. These are all the set options which are turned on. Let's turn off this set option for this session, clear cache, and run our stored procedure. From the execution plan, you can check which set options are on. In the meantime, we open another session and run the same stored procedure without turning off the set option. If you check the plan cache, you will be able to detect different plans are being generated for the same query because of different set options. This small difference you can see might cause different execution plans and different performance among the clients. I hope you now understand how important parameterization is and the way you should be careful. Thank you for watching.